In this video, you will see activities to strengthen learners' sense of volume and the units that we use to measure it. Measures like cubic metres, cubic centimetres or cc's, as well as litres and millilitres. Also, how these units relate to one another. We explore the meaning of the all-important metric prefixes centi, milli and kilo, and make sense of how they all logically fit together as parts of the wider metric system. This exploration moves beyond volume units and delves into many uses of the prefixes within our system of measurement and even beyond. First off, we used a guess, estimate and measure approach to provide a lasting image of a cubic metre. It's an image that comes as a surprise to many people. You'll see how hands-on materials play an important role in making an abstract concept physical. To begin this activity, participants were asked to make a guess at what they thought their volume would be if it was measured in cubic metres. They recorded their guesses privately before we began the estimation phase, constructing an actual cubic metre. This is 1 metre, 1 metre, 1 metre. Okay, I need some volunteers. Can I have a volunteer, please? You can do this very easily. We've got a little join, we've got a little join here, which is very nice, but you don't have to have, you can whack them into a little bit of blue tack or something to hold them together. And 1 metre by 1 metre by 1 metre. Oh, that needs to be right on, damn. Okay, we just need to hold that up there. So we can see how big a cubic metre actually is, which is something that people in the trades should know. Anybody trying to do a garden and order soil should know, and don't, because most people think it's quite a small measure until it arrives on their front lawn and they don't know what to do with all that soil. At this point, when you can all see a cubic metre, it's a good idea to ask if people want to alter their original guesses. Now, how are we going to find out about our volume in cubic metre? The next guess I'd like you to make is how many of you do you think we can fit in that space? Okay, can I have some volunteers? 1, 2, 3, 4, 5, 6, and I reckon we could, if we were prepared to sacrifice them, get a 7th person in there upside down.
At least 7.
Thank you. So how are we going to find out the average volume in cubic metres? We've got 1 cubic metre and 7 people in it. What do we have to do? Divide by 7. So it's 1/7 of a cubic metre. 1/7 of a cubic metre, which is 0.142, which is about 0.14 of a cubic metre. Metres cubed or cubic m. So it's worth going through all that notation with your students too. Now, how close were your guesses?
Pretty close.
Oh, very good.
Small.
So your guesses were quite good? Did anybody guess way out at first? Yeah, a lot of people think that they might be 1 cubic metre or something like that. Okay, well, what am I putting on your tables at the moment? It is a cube. It's the big cube of the MAB blocks, but it's also a lot of other things. I want you to just brainstorm what you know about that thing.
100 individual 1 centimetre by 1 centimetre blocks on each face.
One. Yep.
And there are 10 of those.
10 layers of
It's a regular shape, yes.
Looks like good paperweight.
We can quite easily work out the volume because it's uniform.
Okay, I've asked you a very open question, and I'll talk about that a little bit in a minute, but what do you know about that? It's a 10 by 10 by 10 centimetre cube, so can I just get one thing from each table first off? What?
the cube's got a volume of 1,000 cubic.
Something from here?
6 faces.
6 faces. And did you say anything more about those faces?
Well, they're all the same size.
Yeah? 6 faces equal.
10.
And they're 10 by 10 what?
Cubic centimetres.
No.
No.
They're 10 centimetres by 10 centimetres, which gives us what? What does that tell us about that face?
It has an area of 100 centimetres square.
That it's 100 square centimetres. And that represents what? Well, you just said it, it's area. So we've got 6 faces that are equal and their area is 100 square centimetres. And we can see that if we look at it. Yep, okay. Something from the back table there?
Each layer is 100 and there are 10 layers.
Okay, 10 layers, yep. Can I write square centimetres in a different way as well?
Yeah.
Yep.
Can I ask you, Beth, why do we say it differently to how it's written? Why can't we call it centimetre squared?
That's a really good question. Mathematicians love shorthand, so this is a shorthand, right? But this is how we've always said it. And the square centimetre does describe what we're looking at, a square that is a centimetre by a centimetre by a centimetre. So, yeah, but mathematicians love their shorthand, and if they can find a shorthand way to write it, doesn't mean it'll change what they say, but it will change how they write it.
So CC is the same as CM with a 3.
Yes, CC can also be written as centimetres cubed. So in the engine, what do you think that they're actually measuring when they tell you it's 250 cc's?
How much gas?
The volume of the, is it the pressure or?
You see, this is what all our students think. It's telling us how much petrol you can put in the thing, and it is not. It's telling you the volume of the cylinders, and the cylinders in the engine are what's creating spark and pressure. So 1,000 cubic centimetres is also a litre, and in fact that is the definition of a litre. When they defined the metric system, they said we will take a block 10 centimetres by 10 centimetres by 10 centimetres, and we will call this 1 litre. And do you know anything else about it?
1 kilogram.
If it's water.
No,
If it was water,
if it's water only, because it's got the right end.
yes, if it was water, it would then weigh 1 kilogram. Some might have picked up the anomaly here that we're calling it a kilogram, not a gram, or not the... This was because the whole system was invented by scientists who liked small weights. So in fact, this was their gram, one of these. So what's another name for this cubic centimetre? Anybody know?
1 gram.
It's a gram of water. Yeah, it's a millilitre, because we also know that there's 1 litre is 1,000 millilitres. So cubic centimetres and millilitres, they're the same thing. Except you sort of imagine a millilitre, you can squash it. But plasticine's quite good for that, because then you can fit 5 of these into a teaspoon if you can squash them down. What would this millilitre weigh if it was water?
1 gram.
Yeah. So it's all very neat, and it's so very much not like the system of measurement that some of us grew up with, which was all about chains and people's feet and all sorts of weird things like that, and didn't ever fit together. So we spend half of our primary education learning all these ridiculous 176 naught. Conjure up any?
Oh yeah, the mile.
Yeah, it's yards in a mile. We waste a lot of time learning those imperials, and the numbers just suddenly randomly pop out, and you think, what is that number? Like one's a base 16 and another's a base 12, and so and then there's 22. And whereas the metrics, all you need to know is how to multiply by 10, and you can do everything, and they all fit together. Now what I want you to imagine is, okay, how many of these litres or these 1,000 cubic centimetre blocks will fit into this cubic metre? 1,000. How could we prove that? Can you give Jenny some instructions and she'll come up here and... How are you going to prove that?
I'll just lay them down on the bottom.
Lay them down on the bottom?
Towards on the outside.
The skirting maybe.
Yeah, and then I just try and count how many I can get.
Many would fit around here. 3, 4, 5, 6, 7, 8, 9.
Yes.
No.
No, 10 lines you up with the top there. Yep. So there's 10 along there.
And how many can
They're all the same.
And they're all the same, aren't they, this time? Not like the jelly beans, but we can imagine that we're then going up. Tricky.
But thinking
We can, or we could, yeah.
Would you like to show us a better way, Beth?
No, I wouldn't, but you're doing fine, but we could just get a marker and a pence.
Sorry, keep it still. Didn't you want to count?
No. 20.
We want the answer to be 10, I believe.
Okay. We've got the idea that you can get your students to work it out, and again, they're thinking about this volume business, that first of all you have to work out how many would you fit on the bottom layer, how many layers would go up the thing, so we can work out that there's 1,000. Okay, so what do you know about that then? Can we build a few more relationships from that? There's 1,000 of these things. It's 1,000 litres, yes, which is a kilolitre. What do we use kilolitres for?
Swimming pools?
Swimming pools, or paying for your water?
Rainwater tanks?
Yeah, so we've got 1 cubic metre. 1 cubic metre equals 1,000 litres, which is 1 kilolitre. And if that was filled with water, what do we think might happen? It would weigh 1 tonne. Spelled N-N-E, because it's a metric tonne. While exploring those relationships, we listed a lot of different measurement units. Most of them have prefixes as part of their names. For example, kilolitres has the prefix kilo, centimetre has the prefix centi, millilitre has the prefix milli. When you're doing this with students, it's important to spend some time linking it back to the language. in a way letting them make sense of it for themselves by linking it to what's familiar. One way to do this is to conduct a group brainstorm of all the words they can think of that use these common prefixes. Cent, for example. It means 100. Where else do we see it? Century. Percent. Centurion, which means what?
In charge of 100 souls.
Yeah, they're one of the 100 soldiers, or they're in charge of the 100 soldiers. Centenary.
A cent, 100 cents to a dollar.
Yeah.
Centigrade.
Yeah. Centipede.
Centigrade because,
100 boiling is 100.
yeah, because it goes from 0 to 100, freezing point to boiling point. And centipede because,
Because it's
Supposed to have 100 legs.
it's fallacy. People thought it had 100 legs.
because, yeah, had a lot. So a millipede is even more legs. Centipede, centimetre, of course. Because? 1 metre, right. Century because? 100 years or?
100 degrees.
Or 100 runs.
Oh, yeah. And we used to say to hit the century back in the day when we had a Fahrenheit scale.
Oh yeah, we hit the century 100 degrees. It's really worth weaving the language around the hands-on, around the meaning of it all. And we'll go to the centilitre because somebody asked me that before. CL, centilitre. This, of course, gives us the clue that this unit, centilitre, means 1/100th of a litre. It isn't commonly used in Australia, but in Europe and many other countries it's used a lot. For example, this can of drink will be labelled 330 millilitres here, but in France it's labelled 33 centilitres. The online resource, Building Strength with Numeracy, contains material that complements the activities we've just seen. For example, the activity Knowing the Metric System. This contains prompts for a student discussion about measurement in different countries, including the origins of the metric system and its introduction to Australia. This activity also contains a useful illustrated handout that summarises the main metric system units and how they fit together. There's something for students of all numeracy levels in these activities. Some are useful to find out what they know at the beginning of a course. Others are really useful and fun ways to revise learning from the course.